we've got 2014 GMC Terrain. It's got a 2.4 liter in it, and it's got a check engine light. The owner wants to be able to pass inspections, but obviously the check engine light, she cannot pass inspections. So today, our job is to get to the bottom of that light and figure out what's going on. I already quickly scanned the vehicle, and there is a P0411 code, which is secondary air injection system incorrect airflow. So let me show you guys the check engine light, and then we'll try to get to the bottom of this. I start this car, and then you can see that. Okay, so here it is. You can see the check engine light is on, and we need to try to figure out what's going on. So, let's talk about what the secondary injection system actually does. What it does is it injects fresh air into the oxygen stream upon cold start. And by doing that, it helps the catalytic converter to come up to operating temperature very quickly to make it more efficient. Also, when you start a vehicle from a cold start, the goal of the ECM at that point is to help the vehicle come to operating temperature very quickly so that it can enter closed loop. When that happens, it dumps a lot of fuel into the cylinders, and therefore, you're having a lot of hydrocarbons coming through your tailpipe. So to control those hydrocarbons, we have the secondary injection system pumping fresh air into the exhaust stream to help basically neutralize the hydrocarbons and produce less harmful byproducts of combustion. So basically, that's what it is. All we need to do now is just basically come up with a plan and figure out how to get to the bottom of this. Now, secondary air injection systems are typically made of the pump, the hoses, the sensor, and then a valve, very importantly, actually. The pump basically pumps the air through the hoses, and then the valve opens or closes and lets fresh air into the exhaust stream. And then, obviously, it will close as well to prevent air coming from the exhaust stream back the other way. So basically, that's how that system works. And it stays on no longer than about a minute or two for the most part. It's a very short operation system. It doesn't stay on very long. So let's try to get to the bottom of this. First thing, let me show you the codes so you can see what the code looks like on my scan tool here. So here we are with the code. It says DTC history status history. Now, since DTC cleared, this monitor has failed. And then since last test, it failed also during the last test. So the vehicle has a self-test that it does. So it failed that self-test as well. And then obviously in this ignition cycle, it's not been run yet, but the mill is on. And then the other thing is, sometimes these things, I find people struggle a little bit to understand how this is laid out. You can always go to the global OBD side and read the codes as well. It's much, much easier to decipher on that side of things. So just something to keep in mind. Now, usually with a problem like this, I like to start with visual inspections because we're dealing with quite a good length of hoses because we need to go from the pump to the valve. And that's pretty long, actually. And we also need to go from the air intake system to the pump. So I like to start with just a visual inspection. So let's go do that. So there are two valves. There's one back here. That is for cylinder 1 and 2. Back here on the right side of the vehicle. And there's another one. It's hard to see, but I'll show you guys later. If you can see, now my inspection on the top side doesn't really show any loose hoses or any cracks or anything like that. So I'm going to go underneath the vehicle and look at what things look like. So far, everything looks good here. All the hoses look fine, nice and soft. I don't see any cracks or anything. So let's get underneath the vehicle. And then we're going to do more visual inspection there. And then based on what we find, we can start doing some more electrical diagnostics. Let's go take a look underneath the vehicle. Okay, so the pump is right here, underneath here. Let me show you guys. Here's the pump, right next to the air compressor. And I'm taking a look at the hoses. I don't see any plumbing damage so far. That looks pretty good. Now, obviously, the pump is going to draw air from here into it. Over here, it's going to draw air from the intake system over here. It's going to come through here and then get compressed here, and then it's going to come out to this other hose, this one. So the compressed air comes through this hose here. There's a little cut here as part of the design to prevent it from touching something else, but this is the suction line of the pump, and then it's going to go through the other side into the valves. And so far, it looks good. Anyway. Right, so the visual inspection that I did on the hoses turned out to be pretty good. I didn't find any issues with any of the hoses, so it looks like we're good there. what I want to do next is to see if the output of the pump is actually what it's supposed to be. So there's a spec in the repair information that when the valves are closed and the pump is activated, we need to see a pressure of about 2 psi to 3.6 psi, so 2 to 3.6 psi above barrel. And then when the valves are open, we need to see about 0.7 to 1.9 psi above barrel. So I want to connect this count tool, and then I want to activate the pump and see if the pressure rises to the expected level. And that's going to test the output of the pump. Okay. But before we get to that, let me show you how this is laid out real quick. All right, so here's just a very simple schematic of what the system looks like. Just ignore all these things down here. This is not relevant. But basically, this is the air pump, and it draws air from, there's a suction side, draws air from the intake system right here. And then the air goes into these two valves. So valve 1 injects pressure into the exhaust streams of cylinder 1 and 2. And valve 2 does the same thing for cylinder 3 and 4. So this is the intake, the inlet for the valve, and that's the inlet for that valve. And then basically, they have individual outlets, and both outlets go into the exhaust stream for each of the cylinders. So that's a very simple schematic of what it looks like, just so you guys know what we're working with here. All right, so we're ready to activate the pump, and I just wanted to show you guys. So here, the pump relay is off, meaning the pump is off. You can see here also, obviously here it says off. And then you can see also the valves are closed, secondary injection solenoid valve command closed. The valves are normally closed, and they only open when you want to vent fresh air into the exhaust system. So, and the secondary air injection pressure is 0 as well. Now, remember, because the valves are closed, we expect to see a pressure increase of about 2 to 3.6 psi when we turn on the pump. So let's go ahead and turn on the pump and observe the increase in pressure from what we have here. So let's take a look at it. Now let me get a piece of paper so that we can write this information down. 14.36 psi, and we need to add 2 to 3.6 psi to this. So let's see what we get. I'm gonna go ahead and activate this now. Make sure everything is ready. Okay, all right. We have the valve running, the pump running. We have about 16.24 psi. You can see that right here. 16.24 psi roughly, with the valves closed. So let's turn this off. All right, so we got 0.24, and this was with the pump. This 14.36 was the pump off, and this was the pump on. So we need to figure out the difference, do the math. So what we're gonna do is, we have 16.24 minus 14.36, that'll be 8. The math is coming to call into question here. So that's 8. That's another 8. That's 1, 5. So that's about 1.88 psi. Okay. So about 1.88 psi increase, which is really below what we expect. We expect at least 2, and we're at 1.88. Now, could this be that it's because maybe one valve is stuck open a little bit, or both valves? Unlikely both valves, or maybe one valve is stuck open. It's possible. It's possible. We're going to check that. But now what we want to do is we want to now open the valves and run this pump again. And for that situation, now this is with the valves closed. Okay. Now with the valves open, we expect to see, let me write here so you guys can see. With valves open, we expect to see 0.7 to 1.9 psi, okay, increase from this 14.36 psi in the off state, okay? So now the question is, how do we, I don't know if there's a way to open the, okay, so let's see. I think the secondary injection system activation will open the valves and turn the pump on at the same time. So I think that one will do that. So let's see what we get from that. Okay, so this is on command state again. Now, the one we did before, we had the valves valves closed, we just activated the pump and we got about 1.88 psi. Now this time, I think for this particular feature, we can actually open the valves and also run the pump. So let's see what we get. We've got to give it a couple of minutes for the pump to just kind of cool down a little bit. Otherwise, the computer will lock us out of being able to test it. So let's give it some time. We'll come back and test it shortly. All right, guys, so we're ready to test the entire system now. So it's gonna open the valves and then we're gonna record what we see. So here we have, I think earlier I went with 14.36 for the secondary injection pressure. So I think I'll go with that again for consistency, but we're gonna go ahead and open it and see what kind of reading we get, okay? So look at the secondary injection pressure and then we'll see what we get for that. Okay, so we're gonna command it on and this valve here should be open because it's gonna simulate how this thing actually works. It's open, 1.25, okay, 1.17. I think the max we saw was 1.25. All right, guys, so this is interesting. The max delta pressure we saw was 1.25, which is actually within range in the open case when the valves are open. Now, if we look at the closed case again, we have 1.88, which, you know, should be higher than that. It should be between 2 and 3.6. What this tells me is that it's possible that, you know, before we did this test, my thought process was maybe the pump is not putting out enough, but if you look at this with the max delta of 1.25, it's possible that I don't think both valves, because it's unlikely. I think one of the valves may not be closing well. That's a possibility. It may not be closing well because if it doesn't close well, in the open state, it will show just fine, but in the closed state, it will show lower pressure. So what I want to do next is to see if I can maybe check for a leaking valve. So now you can see I've disconnected the hose that goes to the pump, and I'm going to smoke the hose. With the valves closed, there should be no smoke coming through the exhaust. So that's why this hose is removed. I want to see if any of the valves aren't closing properly. So I'm going to put smoke in here. And if any of the valves isn't closing properly, it should leak and appear at the exhaust. Okay, guys, so next I have a smoke machine here. And I have the smoke machine connected to the outlet of the pump. So what I expect, you know, the smoke, once I turn the machine, I expect the smoke to travel through the hoses. And then when it gets to the valves, here are the valves. This is the valve for bank 1. Here's the valve for bank 2. So I expect that when it gets to the valve, the smoke stops right there and I start to build pressure on the smoke machine. That's if the valves are closed. I do not expect to see smoke at the tailpipe, okay, because the valve should be closed. So we're going to turn that on and then we're going to observe and see what happens to the smoke. Okay, so once it gets to the valves and the valves are closed again, it should build pressure. It should not be able to go through the valves and through the exhaust. We should not see any smoke in the exhaust. Okay, so let's turn the smoke machine on. So I've got the smoke going through all the way to the valves. You can see pressure is building up a little bit, indicating the valves may be closed, probably closed, so you can see the pressure building up. Now let's go take a look at the exhaust and see if we can see any smoke over there. Let's go take a look. Now this is the tailpipe. There is no smoke coming out of the tailpipe. Okay, nothing. You can see that. So next we're gonna go ahead and put the smoke, some more smoke, and then activate the valves and see if we're gonna see smoke here this time. So we are back to putting smoke through it again, but this time we are gonna go ahead and activate the valves. And when I activate the valves, we should see the pressure drop. I'm gonna do that now. You see that? The pressure dropped. So if we let this go for a while, we should see the smoke at the tailpipe, okay? You saw that the pressure dropped as soon as we activated the valve. That shows that the valves are actually working. So if we go to the tailpipe, we should see smoke. I'm gonna try to activate the valve again. Let's take a look. You see that? The pressure dropped. Okay, so turn it off. And the pressure should do it again. So this shows that the valves are working, okay? All right, so let's go ahead and go check the tailpipe here. Okay, this time I expect to see smoke at the tailpipe, so let's go take a look. Right now, looking at the tailpipe, I see traces of smoke, but it's not very satisfactory. It doesn't give me conclusive results, and I'm not really confident in I'm confident in my test, but I want more from this test because I need to make the right call. Now, a couple of things. The reason why we don't see the smoke properly here is because the exhaust is so long that, the vehicle is not allowing us to keep the valve open long enough to allow enough smoke to make it all the way here, because it just allows us to keep it open for a couple of seconds and then closes it. So we're not getting enough accumulation of smoke to come through here. So we need to try something different. This method isn't going to work. If the exhaust was shorter, but how short can it be? Or if we had taken off the oxygen sensor, we could see it probably, but I don't want to do all that. We need to find a different way. So what I'm going to do is probably take one valve off at a time and see if I can activate that particular valve and see if it closes and opens and allows smoke to come through and out of it. I was trying to avoid that, but at this point, this is probably the most conclusive way to figure this out. So let's go do that. Okay, so I've got the valve off now. We're going to go ahead and test the valve directly. So what I'm going to do is I'm going to pass smoke through the hose, the discharge hose of the pump. And then once I pass the smoke, this valve is currently closed. There should be no smoke. And then I will activate the valve and the smoke should start coming out when I activate the valve. So that'll be the verification that this valve works. So let's do that. And then we can go to the other valve. I've got my scan tool right here. My valve is ready to be activated. I don't know if you guys can see clearly because hopefully this is better. I can get it to wedge here. I'm gonna start passing my smoke. There's smoke coming out. Power the smoke machine on. Wait for the smoke to start coming out, and then, okay, I'm gonna put that through the hose. See the smoke coming out. I'm gonna put that through the discharge side so you can see pressure is building up. So I'm gonna go ahead and want this valve open. We should see the smoke. Now there's no smoke, okay? See the smoke coming out right there? Over there, you can see that. It's closed. I'm gonna try it again. The ECM doesn't allow me to open it for long, just a very short time, which is why we didn't get to see it at the exhaust, because it wasn't allowing us to open this valve for long enough to accumulate enough smoke to see it at the tailpipe. So you can see this valve here works, so we verified that. Now we need to move to this valve here. Check for operation of that valve. Okay, so now I have the other valve removed over there. So we're gonna go ahead and test that too. See if I can bring it up a little bit. It's gonna be hard. Little rag underneath so I can expose it, make it easier to see. Okay, all right, so let me start passing smoke. See smoke. All right, I'm gonna pass the smoke. Let me cover this one. See smoke coming out right there. All right, so both valves are working. So obviously the valves seem to be working okay. There's one thing I noticed about this valve though. I wanted to show you guys. This valve seems to have quite a bit on it compared to this one. If you look at it, this one seems to be pretty clear, but this one has quite a lot of deposits on it. This one has a lot of, look at that compared to that. Something to think about. I don't know if that can cause that code. I'm not really sure. See how much this is. It's kind of hard to. I don't know what the inside looks like. I don't know what the inside is gonna look like because it doesn't look very good from here. So based on what I found, I certainly think my problem is the pump at this time. But with how that is looking, I think I might recommend to the owner to change this as well because it's got too much deposits at the end of it. And I can only wonder about what it looks like on the inside. This is not serviceable, so there isn't much to do with it right now. In order to not come back again to this area in the future, I'll certainly recommend replacing this one alongside with the pump. Just this valve here. Yeah, I think this one is okay. So that's what I think. Let me know what you guys think in the comments below. All right, guys, so based on what we found, both valves are obviously working, but the deposits on this one make me a little bit concerned about it. And then it makes me wonder if the valve is looking this bad, what do the ports in the head look like? So maybe I need to probably look at the the ports on the head as well, because all that stuff, anything that clogs or anything that prevents smooth airflow from the pump into the exhaust will probably throw that code. So I think what I'll need to do is look at how much work is involved taking all these things off, so I can maybe see what's going on in the ports. There are some ports back here that allow the fresh air to kind of exit the valve. So I'm curious to see what that looks like. All right, guys, so from what we saw with the valve on the right-hand side of the vehicle, I was talking about the fact that it didn't look good to me. It had a lot of deposits in it, and I was kind of concerned about it. I was wanting to take a look at the SAI ports. Now, in order to get to the ports, obviously you have to take both valves off, both adapters off. The adapters are the pieces that interface with the valves. You see them here shortly if you don't remember what I'm talking about. But there's a left side adapter and a right side adapter because there are two valves. Now, I think the one on the right-hand side is pretty easy to take off, but the one on the left-hand side, it's hard to take it off, almost impossible, in my opinion. You will have to take the exhaust manifold off to get to that adapter, the last bolt that sits at the bottom of that adapter. So right now as I speak, the exhaust manifold is off. I'm going to take off the other adapter. I cleaned out the first one. It didn't look too good. I had to give it a good clean. There was quite a lot of deposits in it. So I want to take off the second one here, and you guys can see what it looks like, and then we can look at the ports as well. I was doing a bit of research. I did a bit more research into this issue, and I found a TSB. I'll put the name of the TSB on the screen there. There's a TSB out for this, in fact, which says if you get a P0411, you should clean the ports. That's something you should do first. So maybe our issue isn't actually the pump like I thought, and I wasn't aware of the TSB, but in any case, when I saw those deposits, I wanted to, go to the ports. So I'm going to take a look at the ports, but, if you don't know, there's a TSB out for this. But I will still replace that valve because it looked too bad, and I don't really want to take chances with it. I'll replace it anyway. The one on the right-hand side, it had too much deposits in it. So after cleaning the ports, I'll replace that valve and we'll see what we get. But right now, let's go take out the adapter and then we'll take a look at the SAI ports. Don't look too good here. I'm gonna clean this out, and you guys will see what it looks like while I try to clean it out. I'm curious to see what the ports look like. We'll have to pick the car up to see what the ports look like. Hard to see from here. I mean, I could use a mirror, but better to go underneath the car. So let's take a look. Now, let me give you guys this view. It's from the mirror, but I promise it's a good view. See that one port is unclogged. Well, because I unclogged it a little bit, but the other one is completely clogged. See that right there? So yeah, I'm gonna spray them all down, clean them up really good. All right, guys, so there's something important that I think I should mention to you guys. Now, when I go to clean these ports, remember these ports are directly connected to the cylinders. So they are 4 ports, right? Cylinder 1, 2, 3, and 4. Now, because of the carbon buildup, I don't want those buildup to go into the combustion chamber because that can cause some form of pre-ignition or detonation, right? I don't want that. So what I need to do is I need to make sure both valves are closed. Now, so I'm going to start from using the harmonic balancer, the damper, the pulley. I'm going to start from cylinder number 1, make sure it's a TDC compression, meaning both valves are closed. And then I'm going to clean number 1 out, okay? And then I'm going to use some shop air to blow it out. So that's why I want both valves closed. Now I use the shop air to blow it out, and then I go to number 2. Now I need to know the firing order for this vehicle. It's 1, 3, 4, 2, okay? After I clean out number 1, when the harmonic balancer is at top dead center, I'll do 180 degrees later. It's 1, 3, 4, 2. So 180 degrees later, number 3 will also be at top dead center. And I'll go clean number 3 out. Then 180 degrees later, number 4 will be at top dead center. I'll go clean number 4 out. And then finally, I'll clean number 2 out. It's important, I think, to make sure both valves are closed because you don't want any carbon deposits getting in the cylinder. I don't want to have this engine detonating or having pre-ignition. Okay, so that is what I'm going to do. So I just wanted to let you guys know. I recommend doing that so you don't put any carbon deposits in the engine. Let me show you guys what it looks like now that I cleared one of them. Let's see, I'm gonna have to use the mirror again. Let's see. So you see, I cleaned that one out. Let me make it bigger. Clean that one out, but the other side is still clogged. Look at that. It's not very clear, but you can see that one side is pretty clean. On the left, now I need to, there you go. I need to clean the other side out too. All right, so let me clean the other one out and show you guys again what it looks like. Remember guys, I just finished number 1, so I'm gonna have to go to number 3, then 4, then 2. But before I move on, let me scrape it a little bit more and then blow it one more time, and then I'll turn the pulley 180 degrees and I'll come over to number 3. Pretty much everything here came out of this adapter. And then there's a lot more underneath this pile of shop rags. A lot of more stuff from the previous adapter. You can see all over here, it's also from this same adapter. Now the trick to putting the exhaust shield, exhaust manifold shield is when you're taking it out, you got to take it out clockwise. When putting it back in, you got to do it counterclockwise. Okay, so taking it out, you got to rotate it clockwise, and then putting it back in, you got to put it back in counterclockwise. So that's what GM says. And I tried it, it works. But you're free to try it too if you want. Here's a new valve. We got a new valve for that one because I didn't like how it looked. So new valve. Put it right back here. And then I got a new gasket made in Japan, but it's a GM part. And that's all I have to say. Make of it what you will. Part number for the gasket 126 42943. Yeah, here it is. All right. Now you put the gasket on, you got to put it on this way so that the top, this piece here is facing downwards. So, just in case you're wondering. And those tabs on it will hold onto the face of the adapter so that it doesn't fall off. You know what? I totally forgot to check the bracket to see if it'll fit before the valves. Will it fit this way? So it's good. I gotta put the connectors in. This connector for that one. An oxygen sensor connector. The oxygen sensor connector has an interesting locking feature. I don't know why this wasn't enough. Just that one locking feature wasn't enough. Anyway, my left hand side first. I don't want to check the repair manual. I'm gonna try to figure this out. Okay, I just need to tighten them down. Ah, you didn't. This is going to be the last act, connecting that discharge hose back to the pump, because remember we took it off to do our tests, so we're going to put it back. Then we can start this car. Everything should be resolved by then. So, okay, hose is on pretty good. Tighten the clamp. We're gonna do one final. All right, one final check. I don't like that. I don't like that. Not at all. Let's take care of that. This is the point of having final checks. All right, guys, so I'm in the car now and started the engine and the check engine light is gone. Just want to show you guys. I'm going to go on a test drive, but I'm not going to put out that on video. Just want to show you guys that the check engine light is gone after cleaning the SAI ports and changing the check valve. So let me show you guys. All right, so here we are. The engine is running and the check engine light is gone. And the code that was there before is also gone. So we should be good to go. All right, guys, so thank you for joining me on this one. I'll see you guys in the next video.